Okay, we're going to do a quick lesson on series and parallel circuits. Last week I taught you guys how to do calculations on series circuits. A series circuit is when you have resistors or lights or different things in a row, in a line. And so we're just going to quickly review series circuits and then move into parallel circuits. So here we have just a basic series circuit where we have two resistors in series and we have an 18-volt battery. Okay, and so here we're going to be looking at this, and one thing to remember about series circuit is that current always stays the same. Oopsie. Is that current always stays the same. And here's our famous equation, V equals IR. Okay, so on this particular problem, we have an 18-volt battery. We have a resistor that's 2 ohms, and we have another resistor that's 4 ohms, and they're connected in series to the 8-volt battery. So how do we solve this problem? First, what we do is we try to find the total resistance. In a series circuit, the total resistance is just all the different resistors added up. Okay, so in this particular circuit, we have 2 plus 4, or we have 6 ohms. That's our total resistance. So over here, we can write a total resistance of 6 ohms. Okay, now that we know that we have 6 ohms and we have a total voltage, obviously, of 18 volts, we can use our famous equation, V equals IR. So our total voltage is equal to our total current times our total resistance. So the total current is your total voltage divided by your total resistance. So our total voltage is 18, our total resistance is 6. So therefore, our total current would be 3, and the units for current are amps. Okay, so I can write 3 amps here. Okay, now if I go to, now that I know the current always stays the same because the flow of electrons, you can't have, it's kind of like traffic. If you have somebody in front of you going 5 miles per hour, you can't be going 20 miles per hour. So the current, the flow of electrons stays the same everywhere. So you can imagine if you have 3 amps coming out here, that 3 amps is the same all the way around. So that means the current here through resistor 1 is 3 amps, and it's also 3 amps over here at resistor 2. So now we can use our equation again, V equals IR, but now we're using V equals I1, R1. So our I1 happens to be 3, right from here, right? And our R is 2. So 3 times 2, and that gives us 6 volts. So our V1, the voltage that resistor 1 uses, is 6 volts. Over here for V2, we do the same thing. V2 is equal to I2, R2. Our I2 is 3. Our R2 is 4. So our total V2 is 12 volts. Okay? Now if we look at this, we can add up. Here we have 12 volts from here and 6 volts from here. 12 plus 6 equals 18. Okay? So that's a series circuit. I'm going to stop this video and I'm going to make a separate video that explains parallel circuits.